Okay, this is Actex 932, and it states that for a certain type of insurance policy, the actual loss has an exponential distribution with the mean lambda. So x is exponential with lambda, and that's your loss. An insurer pays 75% of the loss that occurs. So we know y is equal to 75% of x. So whatever the loss amount is, the payout will be y. Find the moment generating function for the random variable representing the amount paid by the insurer. So we want to find the moment generating function of, we'll say this is s, of that. Now, let's solve this problem. I had a little difficulties with this problem, but I totally understand how to do it now. So first of all, let's just say this. The moment generating function of x, t, is equal to the expectation etx, right? And that is etx times its probability, right? Its probability is 0 to infinity. Exponential, right? We know that it's greater than 0, right? So this is the moment generating function, or at least the definition of it. So let's go ahead and pull out this constant, and then let's integrate what we have here. We're going to pull out x because we know we have dx here, domain. And I always like to say, I always like to pull it up here, knowing that I'm going to do this plus thing here, where then I'm going to say, well, give me my x out, that'll give me my t, plus my y lambda. And this will be negative, of course, because that's the negative goes there. So then I know that this is t plus 1 over lambda. Okay? And those are my little notes of how I do it. Okay, let's integrate it. We know that whatever's this right here, go right here, t plus 1 over lambda. This stays the same. Evaluated from 0 to infinity. Okay? E to the infinity, that's going to be 0. And this right here is going to turn that to a plus. The 0 here goes here, turns this whole thing up here to a 1. So then we get this t plus 1 over lambda. What this is equal to is, I'll just split it here, 1 over t lambda plus 1. Right? All right. Now, that is my moment generating function. Now, I should have stated why I needed it. They wanted us to find this. Well, remember, and I guess I should have done it first, and I'm thinking about it now. I'll probably on the exam just do this first. I probably said, well, this is the expectation of this, of s capital Y. Random variable, small s. Well, let's replace, what do we know? Well, y is equal to 0.75 of x. Aha. now, let's use this, because we do know the moment generating function of x. That's this thing right here. So let's go ahead and state that. This is the moment generating function of t, but t is now being represented as 0.75 s. You see how that? The random variable, I know what the random variable of x is, the moment generating function. I use that, and then using these are my inputs now. Now, easy peasy, wherever I would have put my input t, I put there. So then it'll be 0.75 s plus 1 lambda. Which is t.